And like that, we are live on Facebook. Somewhere I read that keep your friends close, keep your enemies closer. Depending on where you are in terms of your preparation for organic chemistry, it'll feel like a friend to you, it might feel like an enemy to you. But otherwise, keep it close. Having said that, have you paid attention to the pattern of the examination? How it is constantly changing, constantly evolving. In the last 5 years, the average weightage purely for organic chemistry has been roughly 33%. And I think in 2013, it went as low as 28. And then there was 1 year, probably 2015, maybe it spiked up to 40%. And overall it averages to 33%, which roughly translates to about a tenth of your total overall marks. Fine. So if you want to secure, say, between 1000 AAR and 1500 All India ranks in IIT JEE Advanced, then you should likely aim for about 50% of the overall marks, the overall spectrum, the total. Now, to be safe, if you want to crack and get into the top 500, then you should likely target somewhere around 2/3, as in 63, 64, somewhere around that. So where does organic chemistry fall into place in the overall, grand scheme of things? What do we leave? What do we choose? Do we have a choice? So for people who really want the best ranks, there is really no choice. As in, you cannot afford to lose out on scoring from organic chemistry. Now, let me justify that claim. In terms of the three aspects of chemistry, as in physical, organic, and inorganic, straight away inorganic is very memory based, is it not? As in, there are a lot of equations, lots of things going on, and there are very tricky questions which target one particular, exception, and so on and so forth. And then you have your, very stable, dependable, likable even physical chemistry. Somewhere in between, there is the perfect sweet spot in terms of organic chemistry. Now, why do I say it is the sweet spot? Because inorganic is purely memory based. Now, if you're very good at it, snap, 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 you can really score well. Physical chemistry, irrespective of how good you are, you might take time because it involves lengthy computations and so on and so forth. But whereas organic chemistry is concerned, like every other domain of your IIT JEE Advanced, like physics or mathematics or even physical chemistry, so to speak, this definitely it has a very nice logical flow. It has a logical framework. And so people who like logical things which make a lot of sense, which don't put a lot of stress in terms of memorizing things, will definitely take to organic chemistry. Having said that, unlike physical chemistry or maths or physics, definitely you can compute very fast in terms of cracking organic chemistry questions, which means easy marks in just about double quick time or no time at all, depending on how good you are. Most of the times, I just cannot wait to get hold of the latest IIT JEE questions. I look for how people come up with wonderful surprises. What are the obscure things that make me rack my brains, search for that obscure fact here and there, and so on and so forth. Definitely, organic chemistry is not easy, but it is simple in that there are only so many surprises that you could have. For instance, in inorganic chemistry or physical chemistry, they can get you a very lengthy computation question or one very obscure fact somewhere from some random book. For instance, there is potassium ozonide, or there is a reaction between phosphorus and thionyl chloride, something, anything. At a particular temperature, you get different results. At a different temperature, you will get slightly varied results, and so on and so forth. But as far as organic chemistry is concerned, the questions will definitely have to work inside laboratory. It is very logical. It has to be published somewhere. As in, I can't just make up some question of my own liking. So it should work in the laboratory, which means somewhere, definitely, the question is published. Now, with the advent of internet, it kind of makes the playing field very level in that people can go online and check out for different facts. For instance, Friedel-Crafts reaction happens to be one of the go-to reactions in terms of JEE mains, even JEE Advanced for that matter. I do remember there was this one question based on a named reaction which involved a couple of Riddle-Crafts reactions, one alkylation and one acylation, and then the name of the reaction being Haworth reaction. So like these things, there are things which work in the laboratory, and only those things can be tested on paper. So people can't just randomly make up some question, which is very possible in definitely physics, and which is very likely in physical chemistry even. I remember there was one very obscure question where there was an acid rain, and even experts in the field actually had different opinions. So I don't think organic chemistry is as polarizing as other subjects. It's very dependable, it saves a lot of time. Having said all these things, now let us get down to the mechanics, the actual statistics, hard cold facts in terms of what do we focus in terms of organic chemistry. Now in the last 5 years, I think 2012 onwards, I would say that general organic chemistry and nomenclature are at the right or at the top actually, as in you get somewhere around 7%, 1 out of every 14 question. Yeah, it's about 7% of all questions from chemistry. They belong to the chapter's nomenclature or GOC. That could be surprising because what could possibly be tested in nomenclature? To make my point, in this very year's paper, 2017 JEE Advanced, there was one very tricky question where most of students went wrong. I think it had something to do with there are two substituents on a benzene ring where you have a methyl substituent and you have a chlorine substituent, both para to each other. And there were several options, and it was one of those tricky more than one answer is correct questions. And it tripped up a lot of students actually, and it was very surprising because something as fundamental, as simple as nomenclature could be so demanding in terms of putting you to tough decisions. So that is one aspect, but don't underestimate nomenclature. There have been any number of questions. Right off the top of my head, I can at least recollect 5, maybe 6 questions only from JEE Advanced. But yeah, we go back as far as I think early 90s, and then you have general organic chemistry, which happens to be the bedrock of organic chemistry. It is it is the foundation on which the whole edifice is built up, and that is something you cannot take lightly at all. Now if you're one of those students who really gets petrified with organic chemistry with exam approaching in about 3 days, then that is not the time to actually take up general organic chemistry, obviously not. Something being so fundamental, it requires a lot of patience, a lot of attention to detail, a lot of practice as well. So that is something that you should keep in mind. So nomenclature tick, and general organic chemistry tick. These two chapters roughly translate to about 7% of the total marks of all chemistry, going by the average of the last 5-6 years. What about the next most important topic? Now if you look at cold hard statistics in terms of percentages, many people would jump to say that it is going to be the carbonyl compounds or etc. etc. There are other candidates for that. I would say that if you're really serious about cracking the JEE Advanced, JEE Mains, NEET, any exam, you cannot but ignore biomolecules and polymers. Now as much as 4% of all the marks allotted for chemistry comes from these very small chapters. All you have to do is pick up your prescribed textbooks, go through everything. When I say everything, you should remember all the amino acids, their formulae, their stereochemistry, everything there is to it. The stereochemistry as far as different molecules are concerned, names, their stereoisomers and so on and so forth. That is something you have to keep in mind. So biomolecules is extremely scoring, as is polymers and chemistry in everyday life. So if you want to take up JEE tomorrow and you have nothing, no idea about organic chemistry at all, now is the time you pick up your book, hit it hard for about 2-3 hours in terms of biomolecules, polymers, go through all the famous polymers, previous year questions, and you're good to go. There is a good chance that you will actually be able to attack the questions that you come face to face in your exams. That is one thing. And then many people tend to underestimate hydrocarbons. Now, what are hydrocarbons, as in alkanes, alkenes, alkynes, benzene and benzene related hydrocarbons? So what is there? What could they possibly ask? Why is it so important? Many people think carbonyl compounds are extremely important. It is the most important chapter, blah blah blah, and so on and so forth. But hydrocarbons, do not ever underestimate hydrocarbons. I think in 2014 there was this one question which was based on, trust me, Van der Waals forces. You wouldn't believe it. It was just based on Van der Waals forces. There was a 6-member chain, hydrocarbon chain, N-hexane and its isomers, with one branch or 2 branches respectively. They were grouped into 3 different categories, and they asked you to sort the whole thing in terms of decreasing or increasing boiling point. I forget which. Now this is very elementary. Even if you have absolutely no idea whatsoever about organic chemistry, if you can just relate the increasing surface area with increasing boiling point in liquid state, then voila, you can actually crack this question. It's pretty easy, isn't it? And there are those questions like I remember one fantastic question. I think it came right from your Wikipedia page. And yes, Wikipedia page. Of all the technical terms, especially in chemistry, do check the Wikipedia page. This year they had a question from chemical bonding from they wanted you to figure out the geometry of SNF3. That is from Wikipedia page. The Haworth reaction, which I mentioned some time back, that is also from Wikipedia page. You go to the Wikipedia page, scroll down, you have it. There you have it. There are 2-3 questions straight away from that one page from Wikipedia for Friedel-Crafts reactions. And then likewise, there is this question about Wood's reaction. I think they give you something like 1-bromo-3-chloro-cyclobutane. It undergoes a reaction with sodium in dry ether. Wood's reaction, as in, and it would give you a bicyclo compound. It is called bicyclobutyl. That also is, it is. If you just go to Wood's reaction, it is just there on the page. You don't even need to scroll. It is that simple. So check out all the Wikipedia pages. And I'm digressing here massively. Let's get back to hydrocarbons. So hydrocarbons, what are the important things? Whenever you prepare for any chapter in JEE Advanced, do not leave out even the smallest of details. You could do so only at your own risk or peril. Now, it could be very detrimental because, like I mentioned, the question on boiling points. Now, that is not something where you would actually expect a question to come. And under that kind of pressure on the D-Day, when you're actually taking the exam, something as simple as, sorting given compounds in terms of their increasing or decreasing boiling points could be your undoing, and that could be a massive, slippery slope from which everything could go awry. So that is one thing to notice. Whenever you prepare a chapter, make sure you cover everything. Do not cherry pick your favorite topics or your soft spots. Don't choose anything. It's very good to be dispassionate about your approach and preparation towards any particular chapter. What are the other areas? Now we've covered I think Wood's reaction. I think we've covered some parts of physical properties of alkanes, alkenes, alkynes. Another favorite go-to topic in hydrocarbons, especially for I think ethane and butane, N-butane, happens to be conformational analysis. Now I wouldn't understand why JEE doesn't venture into conformations of cyclohexane. That's a different thing. That's a debate for another day. But as far as conformations of N-butane or substituted N-butanes, pay attention to the stabilities. You should keep in mind the entire graph. There is that stability curve which analyzes the different aspects of substituted N-butanes, the gauche formation, eclipsed, staggered, and so on and so forth. I think there were at least 2 stereochemistry based questions from questions on this particular aspect of hydrocarbons. Another really essential topic for hydrocarbons happens to be alkenes. Now in alkenes, you have different mechanisms. For the very first time, you come face to face with regioselectivity, chemoselectivity, different kinds of selectivity. As in, you could get enantiomers, you could get diastereomers, you could get a mixture of stereoisomers, and so on. So bromination in the presence of water, bromination in the absence of water, what are the implications in terms of stereochemistry? That is something you should pay attention to. Also, ozonolysis, I think in the late 90s, there was one question where A gave rise to B, and then B went on to C, A, B, C, D, E, and then they'll give you just one clue in terms of one reagent or one temperature or something, and then they'll ask you to figure out the entire scheme of the reaction. So that also those questions were part and parcel of this chapter, hydrocarbons, because there are not many options in terms of reagents. You could only have bromination. You could have a vicinal or geminal bromination. You could have a halohydrin formation. There are only so many reactions that you could that you need to search for mentally, and then there are only so many options. That is very important as far as alkene chemistry is concerned. Also, what about alkynes? So alkynes is very similar to alkenes. Once again, hydroboration, oxidation, and the reactions which proceed via carbocation formation. All these things become really important. So these are just about the entire gamut of reactions in terms of hydrocarbons. I'm pretty sure I must have left out something, but right off the top of my head, I'm able to recall only these things. So definitely, hydrocarbons, I think it carries around 5% of all marks. Out of 20, you'll definitely find one question in all of chemistry definitely belonging to this chapter, which means it's very scoring. But how do they add a layer of complexity to this chapter, hydrocarbons? Definitely, it happens to be in terms of some form of stereochemistry, be it conformational analysis, or they will ask you to find different products and then ask you to figure out which products, what is the relationship between the products. They could be enantiomers, diastereomers, and so on and so forth. Also, alkene does give rise to a different kind of geometrical isomerism as well. So that is something you need to keep in mind. Further, some alkenes, some hydrocarbons at high temperatures could give rise to benzene isomerization reaction, so on and so forth. Those obscure reactions are also something that you need to keep in mind. So now we have covered GOC, nomenclature, and hydrocarbons. And now we are on to the really big guns, as in carbonyl compounds, aldehydes, and ketones. Now this chapter is just about the whole summary of organic chemistry. Carbonyl group happens to be the most important functional group as such, because it is part and parcel of every other important functional group. So that is something you need to keep in mind. So the variety of chemistry that you get from this chapter is immense. There are any number of naming reactions or named reactions. The least of which, the most famous of which is aldol condensation. So pay attention to all these condensation reactions, aldol, Claisen. As far as I can remember, I don't think there was a question on Robinson annulation. Maybe in the late 90s there was one question on Perkin reaction. Those were the times when because you had subjective exams, they gave you very direct questions and you could just directly write the answers. But now what do? They try to confuse you with very elaborate lengthy mechanism based reactions. They will start with a compound which has one alpha hydrogen, get an aldol product, and that aldol product will react with HCHO in a crossed Cannizzaro reaction, and then once again you'll have an acetal formation. Now for those of you who are in the know, then definitely I'm talking about this year's cracker of a question, one of the best questions I've come across. Really wonderful. Maybe not so much this year, maybe last year, I don't remember which. So the complexity in this chapter, carbonyl compounds, does not come from stereochemistry. So people who are wary of stereochemistry can definitely go with enough confidence, and if you can exhaust your number of searches. There is a crossed aldol, there is an aldol, there is a Cannizzaro, there is a crossed Cannizzaro, all alpha hydrogen based reactions. There is also you will have a cyanohydrin formation, all addition reactions, and so on and so forth. So for carbonyl chemistry, if you can exhaust your search possibilities, there is a good chance that no question is too out there. Whereas in other chapters, there could be some really tough questions which will be really out there in terms of your ability to push the envelope. Fine. So what are the most important reactions? All the alpha hydrogen reactions, aldol, Cannizzaro, Claisen, all the condensations. Keep in mind the different pKa values, the pH, if pH control is necessary for the reaction, the equilibria, so on and so forth. As in, pay attention to everything. particularly the condensation reactions, and also if a reaction could happen in two different media. It could happen in basic media, it could happen in acidic media. So what is the difference, and what are the differences in terms of the rates of reactions? Very specifically, I am talking about haloform reaction. So what kind of substrates give the haloform reaction? Now, why is it important? That is something you'll have to keep in mind. The haloform is probably one of the most frequent reactions which have been tested in JEE Advanced. Apart from, there is one other reaction which I'll come to later. That is not from this chapter. So I think I've pretty much exhausted most of the important topics for carbonyl chemistry. So what about the percentage? I think it roughly translates to around 6% of overall marks that you could secure from all of chemistry, going by the average in the last 5-6 years. And now we have a very simple chapter, very straightforward, the go-to choice in terms of long, lengthy passages, and I'm very specifically referring to carboxylic acids and nitrogen containing compounds. Now I think like hydrocarbons and even like carbonyl chemistry, this chapter also has a weightage of around 5% in terms of overall chemistry marks, but this is a chapter that you cannot afford to go wrong. I'll tell you why. In terms of nitrogen containing compounds, what are the options, what kind of reactions that you encounter? There are two major candidates. One is the obvious Gabriel thalamate synthesis, and the second one is the even more important quintessential Hofmann rearrangement, which is also known as Harmon process or Hofmann bromamide reaction or Hofmann degradation. Any number of names are there. Somehow you get to the isocyanate. Okay, from isocyanate what happens? That is something that you'll have to keep in mind. I think very recently, in the last 7-8 years, I think there was a very direct question where there was a passage given on Hofmann bromamide reaction. They asked about the RDS and and various intermediates and so on and so forth. It was a passage based question, one answer correct, and it consisted of 3 sub questions. So basically it was equivalent to 3 questions with 1 passage, and that translates into a lot of marks. But except these passages, these days, at least in the last 3 years, from what I have seen, the emphasis on one answer correct questions has been dropped a lot, like a real, by quite a margin. More than one answers correct have completely taken over, the scheme of things, as is the case with integer based questions. So as far as more than one answer correct, if I'm not mistaken, from 13, 14, 15, 16 and 17, I think in the last 2, maybe 3 years, more than 50% of all, your marks come from more than one answer correct type. Now that's humongous. That's a lot actually. Now, what are the implications in terms of our preparation? How do we approach this? In that, when you have a question which tests you on multiple fronts for the same concept, it means there is a greater emphasis on your attention to detail. You cannot miss out anything. I remember there was one question where it was a match the following question. The column on the left, each cell from the column on the left could be matched to one or more cells from the column on the right. Now that means for each item you will have to match with at least 4 things, and there are 4 such items, so it's almost like 16 combinations. So you should know everything there is to know about whatever it is that you study. So you have to be really thorough. Make sure that you revise each and every small aspect. If possible, try to make a list or a compendium of try to make notes on what kind of reactions are there. For instance, what are the reactions which are acid catalyzed, and what are the reactions which are acid promoted? What are the reactions which are base catalyzed? What are the reactions which are base promoted? Also, what kind of products do you get? Do you get paramagnetic substances? Do you get diamagnetic substances? When copper reacts with dilute HNO3, what kind of products you get? So when you encounter the products, as in copper nitrate and then nitric oxide and so on and so forth, you should make a list in terms of what kind of paramagnetic substances you have encountered in all of chemistry. Now this might seem like a very tough, steep ask, but there is some logic to it, because you are required to make decisions at a instantly, and under such pressure there is always the chance that more than one answer correct questions that you attempt, there is the greater chance for you to go wrong. So in that respect, definitely your attention to detail and your decision making, what to choose and what to leave, is at the forefront of your your performance in terms of nailing the JEE Advanced. That is something you should keep in mind. So make sure you remember, you pay attention to each and every aspect. What are the other reactions as far as nitrogen containing compounds are concerned? You have physical properties, chemical properties, why the basicity of diethylamine is more than triethylamine, or why it isn't the case, and so on and so forth, based on the different conditions. It could be aqueous media, it could be gaseous phase, and so on and so forth. All the exceptions, make a note of it, revise them, and once you go through a particular chapter, do not relax, and do not allow yourself to take it easy and forget things, because you took the effort to master one particular aspect of a chapter, and then without spaced repetition, if you just let things go off your memory, and you become little slack, and you tend to commit a lot more mistakes as far as your work just piles up at the end of the day. That's the point I'm trying so hard to make. Okay, so we've considered about all the nitrogen containing groups, and amines, cyanides, nitriles, all those compounds. What about carboxylic acids? Are there any named reactions that we should pay attention to? Now, as far as carboxylic acid group is concerned, there are some naming reactions, but I don't think they have ever been tested that often. For instance, there were some very direct questions on HVZ, Hell-Walhart-Zelinsky reaction, but I haven't ever seen a mechanistic based question on that reaction, which means there is a chance that in the future you will actually get. So I'm betting my bottom dollar that you will find a question in the next 5 years based on the mechanism of HVZ. There is one very specific interplay between alpha bromo alkanoyl bromide and a carboxylic acid. That bromine exchange step is what I'm referring to. Pay attention to that. You might get a question anytime. Also, sometimes some reactions will look like Hoffman rearrangement. In that, you have Lawson, you have Schmidt, and you have, I think, Curtius rearrangement. All these reactions happen to be pretty close to each other. So, because the Hoffman bromide reaction happens to be in the syllabus, don't think that these closely related ones are out of the scope. They are not. Definitely they are within limits, and once you get to the isocyanide, from there what happens is what happens. So that is something you'll have to actually pay attention to. When there is one specific reaction as part of the syllabus, there could be a number of other reactions which are very close relatives, okay, siblings. So focus on them as well. Do not ignore them. A small change could put you in trouble in terms of pressure, in terms of surprise element, and so on and so forth. Now, once again, getting back to carboxylic acids, there is this Baeyer-Villiger oxidation. There are different other rearrangements. I don't think there has ever been a question on Baeyer-Villiger oxidation, but lactone formation, and like with nitrogen compounds, lactone formation. All these things are very important. There are some rearrangements like Beckmann rearrangement. Those are things that you might be expected to know. It's better that you actually take care of these things. So that completes carboxylic acids and nitrogen containing elements. Now, what have we left? Have we left anything? I think we've left stereochemistry. We might have left what else? I don't think we've left anything in organic chemistry, or have we? What about alkyl halides and aryl halides? As a chapter, at least in the last 5 years, there have not been many questions. In 2017, there was one match the following question. Maybe it is 2016, I forget. But it involved, matching different cells from the column on the left to different cells in the column on the right. Multiple combination, match the following question, which tested your understanding of SN1, SN2, and so on and so forth. It's very rare that you will actually get a very simple direct question on this chapter alone. Likewise, the same thing holds for alcohols and ethers as well. I don't think there has been ever a question which only was based on ethers or alcohols, except maybe hydrolysis of enol ether. That was one question which was based on ethers. Failing which, I am not able to recollect any significant or tough question that came from these chapters. So I know I've pretty much rushed through alkyl halides, aryl halides. Also, I might have rushed through stereochemistry and the other one, but these are very low ROI chapters. There is one other chapter which I have definitely left out, that happens to be aromatics and phenome. So you have the Reimer time and other named reactions for this chapter. And this chapter also is very straightforward. You don't have that many tough, tricky questions. And this happens to be one of the most scoring aspects with 5% weightage, as in 1 out of 20 questions from all of chemistry comes from this chapter. I think that pretty much concludes all chapters there are. I would just like to elaborate on Friedel-Crafts again. What are the differences between alkylation and acylation? What are the different variants of Friedel-Crafts? So pay attention to that. So that concludes my coverage of the breakup in terms of organic chemistry. Yeah, so now I think I would like to take up some questions. Rahul Maurya from, I think he's in class 11, he's a class 11 student, and he's asking us, how do I prepare for JEE? And he's starting his preparation now. He's in class 11, and what time is it? It's about Dashara time. So I think you have around 8 months and a year. You have a lot of time, but make sure that you stick to the right books, the right preparation material. At BYJU'S, what we do is we know that as students they face a lot of restrictions in terms of time available to be able to study separately. There is only so much time, money, energy that you have at your disposal, and we are very aware of that. And most of the chapters that would normally take you around 3-4 hours of preparation, I think you'll do really well in terms of around 1.5-2 hours with us. It's about 50% of time that you can save. And I myself am involved in putting out the content for you guys. So I think I'm in the right position to tell you that this is a good choice. Having said that, stick to the right books. Do not try to get too many books. That is a trap that a lot of people fall into. You will have to be realistic with yourself, disciplined in terms of making the right effort, making the right timetable and sticking to it. That is something, if you can commit yourself to, it would be wonderful. Let me just take the next question. Ms. Shreya, I think she's asking about the most effective way to study and remember all reactions in organic chemistry. You don't try to remember reactions. Like I said, organic chemistry definitely has a very nice logical flow. A flows into B, B flows into C. There is rhyme, there is reason, there is rhythm even. So since it all falls down into a nice logical pattern, all you have to remember is practice the intermediate steps. What connects A to B, B to C, and so on and so forth. If you remember and practice the logical flow, and definitely you will have to practice solving many problems, so that you never forget. For instance, if I come across a naming reaction, I know its mechanism. 2 days later, I forget half of it. If I don't practice enough, 1 week later, I complete all of it. So this happens to the best of us, to everybody, teacher or student, it doesn't really matter. So practice from the right sources, choose the right material, spend your time wisely. Smart work, like hard work, does pay off. Hard work, although, is inevitable. Yeah. Harihara Sudan, he is asking, how should we study organic conversions? Organic conversions is like picking up a language. If you actually don't practice enough of those conversions, you are not going to be good at it. You might be really good in speaking a particular language on paper. For instance, when I was in school, my Hindi used to be pretty decent on paper, but the moment somebody strikes up a conversation, I am dumbfounded, I don't know what to say. Likewise, if you don't practice enough conversions, that is going to be, just about very difficult to, magically manufacture in your examinations. So conversions are going to be subjective for the most part. I'm not saying that those are not part of your exams. They are part of your competitive exams. They are. But the more you practice, the better you get. Of course, for conversions, you will have to cheat. Let me admit. Okay, there are conversions that you will never get in the first go. So you cheat. You try to attempt it as much as you can, and then once you've exhausted all your possibilities, either it is too simple or too tough, go back to the drawing board. And of course, you'll have to at some times cheat and look at the solutions. So practice as often as you can. That's all I have to say. Aditya, he says he wants some guidance for chemistry states of matter. PV equals nRT. How difficult is it? States of matter. Well, it's a very interesting chapter, but right now I think we are discussing only organic chemistry, so I'm only going to stick to organic chemistry. Maybe some other time, let's do it. Mr. Shashwat Narayan Singh, please explain metamers and differentiate between structural and functional isomers and metamers by amine example. So you have an alkyl group and you have a functional group. Metamers are very closely related. So what happens is, instead of CH2, CH2, CH3, you put one CH3 on the other side. You will have CH3 on this side, functional group, CH2, CH3. Same number of carbons. On either side of the functional group, there are the alkyl chain is different. Functional group isomerism. For the same formula, you have different functional groups. So either you have an alcohol, or you could have CH3CH2OH or CH3OCH3. So these are functional group isomers. So same formula, different functional groups. So that's all there is to it. Mr. Prajwal Kumar has a very interesting question. He's asking, which is the best book to prepare for chemistry in JEE? I'm assuming you are actually talking about organic chemistry. Fine, in the interest of full disclosure, I would like to say that it is our product, but it is our product. And apart from that, if you're talking about some very specific books for organic chemistry, I would say my go-to book is one of the four. You could either pick up McMurray, or you could pick up Wade, LG Wade, or you could pick up, what is the other book? Fryle and Solomon. There is one Francis Carey also. All these four books are very good. For those who want to just fall in love with organic chemistry, do check out Stuart Warren and Claydon. Yeah, I think that's about it. Rahul is asking, how can I get good approach in physical chemistry even if my math is good? Physical chemistry is mathematics. So in math, for instance, if you have probability, basic probability theorem and Bayes theorem, conditional probability. So you have the basics. It has a very, a logical flow to it. Start with the simple problems and slowly progress to the advanced problems. Practice as much as you can. Physical chemistry is not very different from physics, which is not very different from mathematics. Ultimately, it all comes down to logic and practice. Ashwin K. Das. Ashwin K. Das, he is saying, I really wonder what the distribution of marks are in general and which chapters have the highest weightage. I think I've addressed this enough. I wouldn't want to go into it. Do check out our, BYJU'S YouTube channel, where we actually put out some different videos. We put out some different analysis, or we give out teasers and intros for different chapters. We picked, some really interesting, good videos, and we, put it out there so people could come across and benefit from our videos. And then we have Mr. Aman Agarwal. He's saying, sir, what to do for BITSAT exam? Please tell. Basically, see, first things first, for different exams, you have to have different approaches. BITSAT is definitely not going to be the same as your board exam, and which is definitely not going to be the same as your JEE Advanced. First, know the exam, know your enemy, so to speak. You should develop a very logical framework as to where you are in terms of your current level, and where you want to get, as in what a BITSAT topper would do, how they would prepare. For BITSAT, the requirements are very different. You have different types of questions from JEE Advanced. You have very simple direct questions, which may not be very sophisticated in terms of their difficulty or novelty even. You have very direct, simple questions, and the spread of questions across different chapters is very different from JEE Advanced. For instance, JEE Advanced doesn't even go into some topics at all. But those chapters could very well be part of a different exam like JEE Mains or even BITSAT. So know these differences, practice them enough. That is all it takes. What about the next question? Wait, I can take one question. Fine. Miss Neha, she's asking, which is important, carbonyl or alcohol compounds? If you're talking about JEE Advanced, it's a no contest. They are not even in the same league actually. Alcohol, I think it's less than 1% contribution to the whole of chemistry marks. Carbonyl compounds is a hoping humongous, I think 7%, maybe 6, between 6 and 7. I'll settle with 6. So carbonyl compounds, it wins. With that, I conclude this question and answer session.